Welcome to the Real Python Podcast. This is episode 223. Python 3.13 is here. Our regular guests, Geir Arne, Hjelle, and Christopher Trudeau, returned to discuss the new version. This year, Geir Arne coordinated a series of preview articles with members of the Real Python team and a showcase tutorial, Python 3.13, Cool New Features for You to Try. Christopher's video course, What's New in Python 3.13, covers the topics from the article and shows the new features in action. Geir Arne and Christopher dug into the release to create code examples of the new features for the tutorial and course. We look at the options for disabling the global interpreter lock and enabling the just-in-time compiler. We also discuss the new interactive interpreter, better error messages, multiple improvements to static typing, and additional performance improvements. We share our thoughts on the updates and offer advice about incorporating them into your projects. We also consider when you should start running Python 3.13. This episode is sponsored by NVIDIA. Ready to enhance your data science workflows with GPUs? Enhance your skills by enrolling in one of NVIDIA's free self-paced courses at developer.nvidia.com/join. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Well, it's officially that time of the year. Python 3.13 has been released, and my friends Christopher Trudeau and Geir Arne Hjelle are here to speak about Python 3.13. We have had a couple features recently on the site. If you haven't checked them out, we had a preview for 3.13 about the Modern REPL, and then Bartosz did a 3.13 preview about the free threading and JIT. And so that stuff is on the site, and you can check it out. And along with that, Geir Arne just released his Python 3.13 cool features for you to try. Along with that, why Mr. Trudeau is joining us yet again is he's done a video course, which also came out last week here, which would be What's New in Python 3.13. So welcome back.
Thank you, Chris. Always fun to hang out.
Long time.
All right. I thought we'd do what we have been doing in the past here, just kind of break down some of the features. We'll have some of the larger features at the top, and then we got quite the grab bag. There's a lot of small stuff this year, lots of people contributing in ways, and I'm going to include as many of the peps that were involved in these upgrades as possible. And the big one to start with, well, I'm most excited about, and it sounded like Mr. Trudeau is most excited about, is the new REPL. So you ready to dig in, Geir Arne?
Yeah, sure. The REPL has been around forever, and it's very much ingrained in Python itself. It's kind of part of the whole language there, so it's been hard to really fix it. So this has meant that a couple of other more fully featured REPLs have taken over, at least for more advanced developers, like IPython or BPython or PGPython.
Yeah, I think we all have our favorites in our group here.
Yeah, exactly.
That we've been using, yeah.
I'm a IPython diehard myself, but I know others prefer other interpreters. But the beginners will still see the built-in REPL. It's very cool that they've now put some effort into creating a new REPL that has some of these nicer features that we find in the more advanced things, and kind of giving a better user experience for beginners.
Yeah, definitely.
It's been I think a massive undertaking where they've been able to more write it as a separate thing. They were able to base it on a REPL that has been developed by the PyPy team, which is a different Python interpreter, improving on that and then also contributing a little bit back to the PyPy REPL. But I think the biggest kind of features that are in the new one is that we can now do multi-line editing. So when we're kind of writing a Python block of code, say for instance an if statement or a for loop or those kind of things, we can go back in history and edit our block again as one unit. In the previous REPL, you kind of needed to still treat these things as single lines. And if you had a 5-line block of code, you kind of ended up just hitting the up arrow approximately 5 times or something like this just to edit something.
Right.
Which, at least for me, meant that if I knew I was writing any code more than 1 or 2 lines, I would switch to, or I would install IPython and then switch to IPython to work with it.
Yeah.
But now I don't need to do that anymore. I can at least use the built-in REPL for those things. So I think that's kind of the big feature for me, at least. Another one that they're doing now is that they have proper support for pasting code into the REPL, which has kind of been a nightmare before. If you had, again, more than 1 line of code, if it happened to be a blank line in there, it would kind of just jump out of the block you're working on. So defining a class, for instance, inside the REPL was hard and things like this. So that now works much better. And then there's many small improvements all over the place. The tab completion is a little bit nicer. The help menu is more easily accessible. Just you can hit F1 and jump straight into help. They added a history browser, which allows you to at least see your history without all the prompts. So you can more easily copy from your history and put it into some other sources and things like this. So I think it's a great improvement especially for beginners who don't know about the other REPLs, but even just having it easily available wherever you have your Python, I think this can kind of work in many respects like that.
Yeah. Christopher, in your video course, you were showing off hitting the function key, I guess F3 for the paste. Is that right?
Yeah, I think it's F3 for paste. They've tied something to F1, F2, and F3. F2 is the history, so F3 is the paste. Yes, yeah.
So in that, when you're pasting it, that still gives you the ability to like edit it, like the same way that you can edit the multi-line.
I haven't tried, to tell you the honest truth. I think I've always just pasted and then hit enter, but it is now, once you've got it in, it's as a block. So if it did mess up, you could always up arrow and go in and edit it.
Yeah.
I didn't muck around with the arrows after pasting.
Yeah.
Most of the time, if you're pasting in the final carriage return as well. So I'm not sure whether it would handle that or not. I don't know. Didn't play with it.
Yeah. I like that multi-line thing. That was really impressive to me, just to kind of play with it. The idea that you can not only walk back to the last line of that multiple steps, but you can go back and, like, say it was a function definition, you could, change something about keywords or wherever the typo might live inside that.
Yeah, exactly.
Geir, are you on Windows at all?
And not really. I'm mostly on Linux.
No, I was just curious because in mucking around with the history feature yesterday, I was noticing that it's actually triggering less.
Yeah.
We were talking off the air about the fact that you've got all sorts of choices as to how to navigate around up arrows and Vim bindings and Emacs bindings to navigate. And the reason for that is it's using less. And I was just curious as to whether it was doing that on the Windows platform as well, or whether they'd ported a small version of less in, or whether they were actually calling the operating system's browser.
Yeah, I don't really know. I think I kind of heard that. Yeah, they're using some kind of pager. But
so they've probably grabbed a copy of less, is my guess, and just shipped it, because you wouldn't want to guarantee it's there on all platforms. Yeah.
All right.
Yeah, so I'm excited to play with it more. It's nice to have an upgraded version of it. I'm sure everybody who's been using Python longer will enjoy it as a massive upgrade, along with some of the other features that we've talked about across a couple of years. Like we'll mention here more, the error messages continue to improve. So one of the other big features that's getting touted a lot and has been lots of discussions is all about Python's GIL and this sort of idea of making it optional. And do you want to talk about that, Christopher?
Sure. Well, in fact, it goes past the GIL. There are 2 experimental features in this release. And what that means is they're there, but they're not there.
Right.
So experimental features are included in the source code, but can only be turned on by a compile time flag. So they're not in the default builds. So for some platforms, the features are available through the customized installation path of the installer under like advanced options window. But essentially, to play with these, you have to go through extra steps because, well, they're experimental. So as you mentioned, the first one they're calling free threading, and the second one is the JIT. I'll talk about the free threading bit, and then Geir Arne will talk about the JIT in a little bit. So as you hinted at, the free and free threading means free of the GIL. That's right. Certain builds of Python 3.13, no GIL at all. In case you haven't run across this concept before, the GIL is the global interpreter lock. It's a locking mechanism that manages race conditions in the interpreter's memory management code. So the lock is deep in the implementation, so you could easily write all sorts of Python and never come across this. The purpose of the GIL is to make sure that things don't go awry when memory's being freed. And the consequence is it limits the amount of threading concurrency that you can get in the interpreter on a single CPU. There are other ways of doing this kind of memory management. And in fact, other interpreted languages don't use a global lock. The advantage of the GIL is it's relatively simple in comparison to those other mechanisms. And the disadvantage, of course, is it limits your concurrency. There have been attempts in the past to remove it, but the previous attempt ended up working, but at the cost of performance, so it got squashed. This new attempt is being done in a series of steps. So starting out with this release, it's in the experimental phase. It's only available in special builds. If all goes well, then the next phase, it'll be in the interpreter, but only turned on by a flag. And then in the last phase, it'll be turned on by default, but you can still have a flag to go back to using the GIL in case you need backward compatibility. So there are some consequences here for anyone who maintains a compiled library. GIL mode and no GIL mode won't be binary compatible. So the maintainers of libraries like NumPy and things like that get compiled, they'll have to build two versions of their code until this phase is complete. So, Geir Arne, you want to tell them about the other experiment, the JIT?
Right. Yeah, so the JIT, or just-in-time compiler, is also an experimental feature that kind of comes out of the whole Faster CPython project. I believe it's implemented by Brent Buchholz, who's part of that. And as the GIL thing, it's something that you need to activate at build time to get access to. Stepping back a little bit to say that Python is an interpreted language in contrast to things like C, which is compiled. But adding a JIT compiler to Python essentially means that some code will be compiled while the code is running, as the interpreter kind of figures that, okay, here we can speed up this code because we keep repeating it, is kind of the idea. It's using a fairly new method for doing JIT compilation called copy.py, I believe it was called. The idea is that you kind of have some of these templates of code that you can kind of speed up, and then you just fill out the template with the actual values of variables or pointers and references and things like this. What the JIT compilation would be able to do then is to take calculations where you kind of keep repeating them over time, or similar calculations, and then kind of just say that, okay, this piece of code, we should just compile it down to something that runs quicker than just the bytecodes that Python usually runs. In our experiments, or the experiments that Bartosz did in his preview article, he was able to see a small improvement in a couple of benchmarks, and then in others there was less so. And I think the goal of this experiment for 3.13 is kind of just see, can we make it more or less as fast as the regular code, which is already not trivial because you're doing quite a bit more when you're running through the JIT to kind of monitor which things we try to optimize and so on. So it's looking promising. And I think part of the idea here is that, okay, we'll experiment a little bit with it now and then expand on it in future versions of Python. And hopefully it will kind of be something that can be activated fully. This is, in a sense, I guess, a much smaller change than the whole removing the GIL, which has been a very intricate part of Python forever. But at the same time, it is kind of changing some of the core ways of how Python is running. So it is a big thing that could kind of pave the way for some other optimizations later. So it's interesting to follow.
I'm really intrigued by like what is going to happen in the larger communities and outside the core development of it now that it's being released and what the embracing of it will be like. I've talked about a couple different JIT type tools before on the show with Anthony Shaw. He was working on a project called Pigeon.
Right.
So it's been an intriguing area to again, watch this space. And if you want to, you can now play with this space.
There's a lot you can do to fine tune it as well, right? So like a common approach is to just go after things like your tight loops. So if there's something that is happening, you've got a loop that's going to run 100,000 times, that's a place where spending the cost of doing the compilation makes a lot of sense, because then you can pay the compilation cost and then gain the piece afterwards. So it's one of those things that can be turned up and down, right? It doesn't have to be an all or nothing, which gives the core developers sort of a lot of tools for finding places that can help improve performance.
I definitely see it in the data science world.
It actually might matter less there.
Oh, really? Interesting.
Well, because most of the data science world is already in NumPy and Polars and those kind of places, so they're already compiled.
Offloading a lot of it.
Yeah.
Okay.
So it might help the data science world where you were doing the thing which you weren't, which is iterating over the data frame. And if you had just stayed in the data frame, you wouldn't have to do that in the first place. Yeah. So it'll be interesting to see how that shakes out.
Okay. So, Christopher, you want to talk about this onward progress with error messages?
Yeah. So the error message thing's been ongoing for the last few Pythons. Personally, I've found this really helpful. It's been easier to understand things and hunt some stuff down. Most of the heavy lifting was done, I think it was 3.11, but they do still keep tweaking things, and 3.13 has a few more tweaks. The first one is actually a theme of this release is colorization. It's showing up in all sorts of different places, including the REPL. Tracebacks on the command line are now colorized, making it more obvious which part is the error, which part's the stack trace, where your variables are, that kind of thing. And in fact, if any of the maintainers are listening, I have a suggestion. The Django debug page stack traces have a actual highlighting for code that is local versus code that's in the third-party library. So it actually makes this is your code pop when you've got a giant stack. So it would be neat to add that for maybe 3.14. But anyways, so in addition to the colorization, there's two new improvements that have to do with imports. If you've ever accidentally named your script the name of a module in the standard library and then spent a whole bunch of time scratching your head wondering why you couldn't import something, well, now if you're getting that kind of import error and your script name shadows a standard library module, the import error includes the hint, consider renaming your file since it has the same name as a standard library module, which is nice.
Yeah.
And there's also a hint for the more general case. So when your file doesn't shadow something in the standard library, but you have an import error, the hint warns that you might be shadowing a third-party library. I'm actually not sure how I feel about this one. It's just general help, and it isn't actually detecting whether or not you're shadowing something. So I'm worried that this help will confuse people and send them off looking for a problem that isn't there. So I'm pro on the standard library shadowing. On the hint here, I could swing either way. And then the other error improvement is they added did you mean capabilities quite some time ago. A couple of releases back, they've added more of them here, and now they're for keyword arguments. So if you misspell a keyword argument, it might be able to guess what you meant and give you a hint.
Yeah, it's nice to see the improvements of pointing at things was over the last couple of versions, kind of like the little carrots underneath stuff kind of pointing like this is more specifically, not just the line number, but the area of the code. So adding some colorization is kind of nice too. And yeah, it's nice to keep seeing these improvements. Looking to GPU accelerate your data science workflows? NVIDIA provides extensive, industry-leading training on the creation, acceleration, and deployment of data pipelines for data science workflows. You'll also find hands-on courses on integrating accelerated computing and AI to help you build solutions to the world's biggest challenges. Take advantage of this opportunity to enhance your skills by enrolling in one of NVIDIA's free self-paced courses at developer.nvidia.com/join. All right, that gets us into talking about static typing. And so, Geir, there's a whole bunch here. And so I was trying to figure out how much of this can we cover? But the improvements continue on.
Yes. So the static typing landscape in Python, I guess it really was introduced, back in Python 3.4, 3.5, thereabouts. And then ever since, there's kind of been small steps towards some kind of better future. And this time around, I guess there are 4 steps at least that are highlighted. So I'll quickly cover some of those. So one is just that you can add a deprecation warning in the static typing system with the decorator. It's something that you can add to many different code objects, including, I guess, modules, classes, and functions, and so on. It's something that can then be used to tell your users. So typically this will be for library maintainers, I guess, that you can tell your users that, okay, this function should be replaced with something else. And you can always add a comment into the decorator telling the user what they should be doing instead.
So this would appear not as a warning when they're running the code, but when they're running a type checker.
Exactly. Yeah. So
Okay.
so you can kind of catch things already at that stage.
Okay.
Which I guess nowadays, so in the early days, running a type checker typically meant that you actually physically had to type mypy and something. But now the most linters, at least for, say, the big editors, do run the type checking for you. At least you can turn it on to do so. So you'll even get some squiggly lines, or I think in VS Code, it actually just even strikes out your function call and then suggests that you switch it to something else.
Okay, great.
With that deprecation message. Then another update is just a continuation of something that came in Python 3.12, where they kind of changed the syntax in how you can work with type parameters or type variables, which is typically something that you'll use when you have, say, data structure, nested data structures. So instead of just saying I have a list, you can say I have a list of strings or something like this. So you have a generic in there kind of saying that this list will contain strings. And you can do this with your own classes as well. So I think the example we used was of a queue data type that you can just, okay, this is a queue of integers, for instance. And they just added a small thing there where you can have a type default in those kind of generics. So for instance, if you have like a queue data structure and you just initialize an empty queue, then it's not immediately clear if this is a queue of integers or strings or what is the data type that should be contained inside of it. But this is something that you can kind of say, where you would say, okay, I initialize a queue, and I think the syntax for this would be then to have a queue square bracket str, for instance, if it's a queue of strings. But with the new defaults, they kind of operate similarly to how default variables operate in regular functions. You can also just say, okay, the default type for this queue generic is strings. And then if you just say I'm creating a new string, then it will be assumed that this is a queue of strings. So just tiny little addition to the big thing they introduced last time.
Yeah.
Another feature which also kind of comes on top of an earlier one, I think this one goes back to Python 3.10, which introduced something called type guards. And they kind of have realized that the type guards, there are some use cases where it doesn't really work as it should. So they kind of needed to improve on it. And they've ended up creating something that's almost a type guard, but it works slightly differently. It's called TypeIs. And I think ideally they would probably have just gotten to the TypeIs at the very beginning, but because of
right,
it takes time and experience and things like this to kind of figure out how everything works.
Yeah, people got to use them.
Exactly. And I think that there might still be some use cases for the old behavior of type cards. But yeah, what are these type cards or TypeIs things? It's when you have sort of like a union type. So say that you have, say, a tree class or something that can have a node, and that node could either be the value or it could be another tree, a subtree essentially. So then when you're dealing with this, you'll have to annotate your functions saying that, okay, this child can be either, say, an integer or a tree. So coming into the function, you don't really know what you have. But then before you can kind of do any operations on it, you kind of need to know, is this a tree or is it an integer? Then Python supports some of the basic ones already, or I guess the static type checking does. So you can check for none, for instance, which is the typical if you have optional stuff. And if you then have something like if your variable is none, then do this, then Python can kind of figure out that, okay, if it's not none, it's a string. So type guard is essentially just generalizing this, so you can create your own functions that can just check, is this a tree or is this a positive number, or those kind of more advanced checks. And then you can do the if test. as it turns out, the old type guard is only able to narrow, as we call it, the type in the positive if case, essentially. So you can do if is tree, and then you have a tree. But then in the else case of that if statement, the type checkers assume that, well, it's still either a tree or an int. It doesn't realize that, well, the tree would have gone in the first if. Yeah, I haven't really read up on why they chose that design, but they have kind of figured now that it's better to have the else case also more powerful than actually narrowing down on the else case. So that is what this type feature will be doing.
Okay.
And the final and fourth feature that we're highlighting is also referring back to an older one, which was the TypedDict, which are essentially dictionaries where you can list keys and with their types. So you kind of put some structure on dictionaries. I believe this was introduced all the way back in Python 3.8 probably, and then they kind of added a few improvements as time goes along. And the one that's coming this time around is that you can mark some of your fields in the dictionary as read-only, and then the static type checker will tell you if you try to mutate the values in it. This could be helpful just to keep you honest in a sense, but it also has some consequences for the typing itself, because when you can mutate everything in a dictionary, then you can't really say that two typed dictionaries that looks like they are almost equal are actually equal, because things could have changed. So you're kind of getting some stronger guarantees by using the read-only in there.
So it would actually flag that somebody changed something in this. The code would run, again, dynamicness of Python. But in this case, the type checker would actually say, hey, this was intended to be a read-only thing and somebody changed it.
Right. Yeah. You can't update the key because it's a read-only key.
Okay.
Essentially. Yeah. So the name of, if you have a person dictionary with the name and you mark the name as read-only, then you can't have code that goes in and updates that.
So I'm guessing this will all be much easier to check out. If I know that, going through the video course, it made a lot more sense with kind of the examples and seeing it there. And then we'll have obviously the real Python tutorial. We'll go much more into depth to kind of show you. And then I have links to every one of the PEPs, 702, 696, 742, and 705 that would give you even more details and examples. So we have kind of a small change here, but a welcome one. Next, Chris?
Oh, I'm disappointed you didn't ask my opinion on typing. I think I've established
right past it.
I can't imagine why.
I think we recorded that from last year. Right?
Yes, it saves time. He can just edit it in again. I think we've had the conversation a few times.
Grumble.
Yeah, so there's a whole bunch of modules in Python that provide command line tools that you can use in the terminal or like in shell scripts. My favorite example is json.tool, which is a JSON pretty printer. You access these kinds of command line tools through the -m argument to Python. This release has added a new utility of this sort, and that's for the random module. You can now call it with -m. It provides a randomization service, which comes in 3 flavors. Flavor 1 is used to randomly pick from a series of choices. You provide the command with arguments, and it randomly returns one of them. Flavor 2 is a random number generator for integers. If you provide a single integer as an argument, then the module will return a random integer between 1 and that number. And the third flavor is floats, which provide a random number between 0 and the number you gave. Should provide a number between 0 and the one you gave. There's actually a bug in the release candidate that it's been doing 1 instead of 0. I haven't validated in the full release yet whether that's been fixed, so we'll see. And in case there is some edge cases where you're worried about the tool not correctly guessing which flavor you want, there are also flags you can use to force it. So say you want an integer as an argument, but you want to treat it as a float, you can do --float, and it forces that float flavor that I was talking about. And then likewise for --choice and --integer.
Can you specify 2 values?
No, I you know what? I never tested that for the integer. I suspect not, because I did test just without the flag and putting in multiple integers, and it immediately went into choice mode. So I suspect it's using, multiple arguments as, hey, you're in choice mode. And if you're putting 2 integers it doesn't really make sense because it's always between 1 and that value. So I don't know what the second integer would mean. Don't know whether or not it gives you an error in that case. I would hope so.
Okay. This next one is kind of interesting. If you've ever needed to copy objects before, I'm intrigued by this one a little bit. So you want to dig into what's changing here?
So they're adding a new function to the copy module, which is called replace. And I think before, I mainly only used deep copy from the copy module, which is a nice function when you kind of need to really copy, say, nested structures like dictionaries and lists, because if you just do a regular copy on those, it will kind of create a copy, but if you have a nested list, you'll kind of get a reference to the exact same list and so on. With the deep copy, you'll get proper copies all the way down. Yeah, the replace is something that's meant to work together with immutable data structures. So tuples kind of comes to mind, frozen data classes and things like this. And the idea is that you're creating a copy of the immutable data structure, but then you're changing some value. So you're kind of replacing one or more values as you're doing it. I kind of like this. I tend to try to steer towards mostly using immutable data structure, or if I'm using lists and dictionaries, I'm trying not to mutate stuff anyway. So kind of having a little bit more support for working with immutable data structures, I think is great. The way it works is just that you will be able to work with name tuples, data classes, and a couple of standard library data structures like date times and things like this is kind of supported already. And then you can also add in support for this in your custom classes. And then when you want to make a copy, you'll just call copy replace with the original object, and then you can just add in, say, comma, whichever fields that you want to change. So say you have a name tuple for a person that has a name and a location maybe, and you want to copy it and change his location, you kind of just say copy.replace, send in the person object, and then comma place equals new place. So it's a little thing in a sense, but I think it will make working with the immutable data structures nicer and also more consistent. Essentially the same thing already existed on data classes, where you could get the replace function from the data class module. And also date times already have similar things built in, but now you kind of have something that in theory should start working for all kind of immutable data structures.
Your reasoning for using more immutable stuff than like lists and dictionaries, what are the advantages, that if you can say it briefly?
Mainly that it's easier for my brain to follow my code because I know when state is changing, so to speak.
State will be the same, yeah.
State will be the same. And I guess Python has its own troubles with this, but it also makes things in theory easier to parallelize and things like this when you're not changing things.
Usually smaller, right, in some ways because of the immutability of them as far as like the memory footprint and things like that.
Yeah, you can kind of do things like caching much more easily, for instance, because the object will never change, so you can do some of those kind of performance optimizations. What it may lead you down though is that you're making more copies, which could potentially eat up your memory a little bit more than changing stuff in place.
Yeah, still need to pick the right data structure
right
for the use case. Yeah. For this week's Video Course Spotlight, I want to remind you that Christopher Trudeau has created a video course all about this week's topic. It's titled, What's New in Python 3.13? In the video course, you'll learn about the new features and improvements like advancements done in removing the global interpreter lock, or GIL, and making Python free-threaded, the implementation of an experimental just-in-time, or JIT, compiler, improvements made to the interactive interpreter, or REPL, clearer error messages that can help you fix common mistakes, a host of minor upgrades to Python's static type system, and much more, as you've heard throughout this episode. Like all the video courses on Real Python, the course is broken into easily consumable sections. Plus, you'll get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using our search tool on realpython.com. All right. So, Christopher, you have a little bit about working with files in Python here, some updates.
Yeah, I also just tested your question, and it just ignores subsequent integers.
Okay.
For the random. It just gives you a random number for the first one and ignores the rest of the arguments. So no error, just does it. So
okay.
Yeah, so the Pathlib module gives you the path class, which abstracts file name paths, and you can use path objects to manipulate files. It can basically do everything that the OS and os.path modules did or do, but it's a little more modern way of making your code far more readable. This release has a few improvements to Pathlib. The first is connected to file URIs. That's a URL-like thing that points to a file. You can already use as URI to print out a path as a URI, but now you can also use from URI to construct a path from a URI string. So this allows you to sort of go back and forth in either direction, which before you could only go one way.
So the URIs, those kinds of things that they kind of look like a URL, but they'll say like file : / /
Yeah, file : 3 slashes, etc., hosts or whatever. Yeah, URI is actually the more generic version of a URL. The URL is the web-based thing, and the URI is the universal.
Yeah, link versus, I don't know what the I is.
Although they're both universal, yes. But yeah, anyways.
Okay.
Subset, superset, whichever it is. The math guy will pick in and get that right for me. So the next addition to Pathlib is the full match method. This is a name comparison method that supports the star and double star wildcards. Using this, you can do something like full match star.py, and if the path ends in pi, you'll get back true, and if it doesn't, you'll get back false. The double star wildcard allows for descent matching in a directory structure as well. So it allows you to sort of look for that file pattern further down in path hierarchy rather than just in the local directory. Note that full match works on path objects, meaning it doesn't actually have to be attached to the file system. So it really is just a pattern matching thing in the name. And speaking of files on your system, prior to this release, there was a little weirdness that was kind of a gotcha in the glob and arglob methods on path objects. These two methods are kind of like that match mechanism that I just talked about, but they return a generator pointing to actual files that match a given pattern. So if I go back to my star.py example, if I glob that, it'll give me all the Python files in the paths directory that match star.py. The weirdness comes from how it used to implement the double star. In other programming languages, and in fact, elsewhere in the Python standard library, double star means files or directories. For some reason, the original implementation of glob and arglob only returned directories. So you had to go off and get the directories and then do another call on those to get the files inside of them. This has been changed to match the more common expectation. So double star on the end means files or directories. And then finally, several of the path methods now support arguments having to do with symbolic links. Changing these flags changes how the path method behaves when it comes across one. So for example, is file, you can say whether or not a symlink to a file counts in your test or not.
So symlinks, for somebody who's not familiar with it, it's sort of aliasing like a location somewhere else on it, like another directory.
Yeah, it's a Unix-based mechanism. It's kind of like the shortcut on a Windows desktop, but actually built into the file system. And for most cases, you want to treat it like it's the file itself, but there are cases where you have to be careful about it. Because it can be a file reference, you can symlink back to a directory that is the parent or the grandparent of the directory, and that can get you into recursive descent problems. Being able to turn these kinds of things on and off in different situations just gives you more power. You can make the choice yourself.
Cool. So this kind of got us into the next section of upgrades, and we figured we'd do sort of a bit of a grab bag of other goodness that is coming here in Python 3.13. So, Geir Arne, you have a handful of them. You ready to dig in to the grab bag?
Sure. I've grabbed some stuff out of the bag there, so let's see what we found. So mainly there's many of the small performance improvements. So Typically, I guess each release, Python tends to be slightly faster than before in different aspects. So it doesn't mean that all code runs faster, but at least some code will be faster. And one kind of interesting optimization they're doing, which I guess probably saves more memory than speed, is that they are stripping docstrings before saving them now or storing them. So typically you'll have your docstrings defined on, say, a function or a class. And because the function kind of requires things to be indented, each docstring will have at least 4 spaces before every single line. And similarly for classes and methods, even more so. These spaces have been stored together with the docstring. So when a class is defined or a function is defined, the docstring is stored in the dunderdoc attribute, including all of those spaces. But beginning in Python 3.13, they are stripping off common leading white space, essentially, so that those 4 spaces in front will kind of be stripped. They're not stripping all the white space because you might be using it to kind of format things nicely in your docstring, and that is still kept. So this shouldn't really be something that you notice much, but it is kind of saving a little bit of memory as the code is running. And if you have tools that either test directly against the docstring or use docstrings very explicitly, you might need to do some updates there. I think when they first implemented it, there were a couple of failing tests in different libraries that were just double checking that the docstring is exactly this, and then it suddenly wasn't. But in general, it's just a tiny little optimization thing. They also done some cleaning in different modules to make their imports faster. I guess what used to be a big one here was the typing module that used to be very slow to import, and they have improved it earlier, and there's less stuff in the typing module than it used to be. But that one has gotten a nice performance boost, and also some other modules in the standard library has gotten faster. And then a couple of things that don't go directly towards performance. One is that importlib resources, which is a module that you can use to kind of work with, say, data files and those kind of things through the import system. Typically, those most of the features in the importlib resources were dealing with files directly, but now you can also address directories using importlib resources. And finally, the thing I want to mention is just that iOS in particular, but also to some extent Android, have gotten more official support, I guess, from, I don't remember the exact term they're using, a tier 3 supported platform. Is that it? So in theory, at least, it should make it safer, I guess, to use Python on those platforms. There will be more support for it. But it's still not one of the major platforms. But
yeah, I was just looking at it. I've talked before about the WASM platform, with Brett Cannon, talking about the WebAssembly 32 and so forth. And that started at tier 3. So I think it's now tier 2. So it's one of these things that it's, you kind of walk up the tiers and it'll be more and more support and looking at it. So definitely something Russell Keith McGee is working on. I hope to talk to him about it more.
Yeah, exactly. So I think that leaves my grab bag empty. So
all right. Christopher, you ready to dig in?
Yeah. I got the last few here. So first off, you may have used the locals built-in function, which displays what values are in the current context, so your variables and things. Several versions ago, the underlying container for this was modified for performance reasons, and what was in locals for functions in particular got changed. What wasn't changed, however, was other contexts like classes, and this led to an inconsistency and actually a couple of bugs. And so, for example, values within a comprehension in a function would leak into the context, which they're not supposed to. Comprehensions are supposed to be self-contained, but then it wouldn't do it in classes. This release includes PEP 667, which makes this behavior consistent once more. Unless you're actually playing around with sys getFrame f locals, you'll never notice this at all, but consistency is good, and it tends to mean less bugs. So for the core developers who do touch this stuff, it's a good thing. To go along with the deprecated decorator that Geir Arne mentioned is a deprecated method argument in the argparse library. This allows you to set a flag to indicate that some argument in argparse has been deprecated and you shouldn't use it in the future. And to go along with the colorization stuff that we've mentioned is the colorization of doctest as well. So if you use doctest, you'll now get similar highlighting to the REPL and error output that we've mentioned before. This next one is simple, but I like it a lot. If you've ever used breakpoint or setTrace, the functions, to programmatically insert a breakpoint, you may have run into the situation where the breakpoint was the last line in a function or script, and the debugger wasn't sure where to do that, what to do with that. The entry point to the debugger was always the line after breakpoint. And of course, if there's no code after that, the debugger can be a little strange. So Python 3.13 has changed this behavior. The entry point to the debugger is now on the breakpoint function, meaning it doesn't matter where you put it, and it will be where things stop. So just a slight clean thing, but it helps cosmetically if you happen to use this.
That's with the internal PDB debugger.
Yeah, essentially, it works in any debugger. If you're used to using this in an IDE where you're clicking on the line, then this isn't going to impact you. For those of us who still use the terminal for this kind of stuff, this is how we put breakpoints in things. So yes,
right.
So this is that. I like this one because it helps me. Enough about me. What do you think about me? But anyways, and last thing is there has been a large ongoing project over multiple releases here to remove modules from Python that aren't used much anymore. These modules have been called dead batteries. Most of these got deprecated a few releases back, and the last big chunk of this has now actually been removed as part of Python 3.13. That doesn't mean they won't continue to deprecate and remove things, but this was sort of a big thing that started 3 releases back, I want to say.
Yeah, what I'm wondering about is, as being the newest person using Python in this group, has Python always been celebrated as a batteries included
language? It was the selling point in version 2 when I picked it up back then. So yeah.
I think that was something that came very early, and I think it was much more important back in the 90s because packages were hard to install, if ever, and I think the way you did it was kind of by sending stuff by email almost, or something like this. There wasn't a PyPI that you could just do a pip install from.
So having stuff built in was really a boon in a way.
Yeah, exactly.
And it was a distinguishing factor between other coding languages as well, because those that did have package managers, they tended to stick everything in the package manager. And so you were always doing that. And because Python started out as just hey, let me fire that thing up on the command line, having those things there meant, I could do this without having to go and install 4 more things, right?
Right. Very often what we get into at the end of our reviews of a new version of Python is, well, what should you do now? Should you upgrade right now? And so I guess we can kind of make a round on that. I personally feel that for the things that I'm doing, Python 3.13 shouldn't really propose any issues. And I look at my use in the REPL. We recently had last episode, we talked a little bit about our own setups, and I have a couple of versions of Python running to test different things and make sure all my projects are running. For me, my main use is it looks like I should be able to move in pretty quickly, and I'm excited about a handful of these things. So do you want to go next, Geir?
Sure. Yeah, I agree. I think I'm at the place where there's no big reason for me to upgrade. But if there's something, I think that the REPL thing, just having that one easily accessible, is probably the big one. At the same time, there's no big reason for me not to upgrade either. Often I kind of look at should we upgrade from a couple of different angles. One is kind of should I change what interpreter I'm kind of running stuff on? And for this one, I guess because of all the work and all the changes they've done to the GIL, I'd maybe be extra careful this time around if I'm running something very important in the production, and make sure I kind of test stuff properly and things like this. But for my use, I don't think I need to worry too much about it. Even though they've done the big changes, they've also done a lot of testing and things like this. The other question often comes down to, well, should I start using the new Python 3.13 features in my coding?
Right.
But this time around, I think there's very little that isn't backwards compatible. I think, well, if we start using copy.replace, for instance, that will be a 3.13 only. There's some of the new things and changed behavior in Pathlib and so on. But most of the things are things that we can use now. The typing stuff typically gets backported through typing something direct module that you can install. In a sense, I think I'm in no rush to update, but also nothing stopping me from updating to Python 3.13, I think, this time around.
One weird one, I think, is the doc test thing. If you are doing lots of doc tests yourself, that formatting issue might be something you'd have to look at compatibility-wise. But you're right, there's not structural pattern matching. There's not Walrus operator. It's not these other kind of changes that potentially version-wise could get you in as much hot water. Again, we're still at the beginning of this here, but I'm not seeing as many.
And another reason traditionally to kind of hold back a little bit on upgrading has been support from libraries. They often take some time to support the new stuff. My feeling is that this time around, at least the ones I've been kind of looking at in the data science space, have been quite proactive on being 3.13 ready.
Yeah.
And I think to some extent also the call for, make sure you can deal with the GIL and those kind of things have kind of been heated, and people have done some work during the beta phase on it. So
good. What do you think, Christopher?
What he said. Got nothing to add.
Nothing there. What about Django? Does it look like that's one of your main platforms you use a lot?
Haven't played with it yet.
Okay.
I don't expect there to be anything here that, like even with the third-party libraries, unless the library is trying to take advantage of something, as long as there haven't been backward compatibility changes, it's not like I can't go install a library that hasn't been touched since 3.10. It's still Python, right? So the only real boundaries here are things like, the ABI boundary, and that's only if you're mucking around with the new no-GIL stuff. So at least for me and for anyone who's touching production code, you shouldn't be using experimental anything anyways. So I don't expect this one to be problematic.
We didn't really touch on it too much, but generally they have continued the trend of speeding up Python. I don't see it as a big advertising thing on this version. Have you heard more on that at all, either of you?
I think the concentration has been on the GIL and the JIT, right?
Yeah.
Because that, in theory, should provide those things down the road. So I don't think there's been as much focus on it this time around.
Okay.
And they usually tend to scream about it and print pretty graphs and go, look what we did. And,
we did it.
And now it's more of, look, we didn't break it. So yeah.
Sure. Yeah.
Yeah, exactly. I think both for the free threading and the JIT, it's been more, we managed to do this with more or less the same performance as before, which is also a huge accomplishment and kind of lays the groundwork for future improvements, I think.
Yeah, definitely. So again, if you haven't checked out all the resources that we have on Real Python, we have the two previews we mentioned, the one that does dig much deeper into the free threading and JIT compiler by Bartaj, and then Geir Arne gives you a really good preview of what's happening in the new REPL. And of course, our main release there, the cool new features, which reiterates a lot of stuff there. And then Christopher's course, which is again called What's New in Python 3.13. Is there anything else you guys wanted to talk to on 3.13?
I think I'll just give a small shout out to, I guess technically some competitors of us, but mostly friends of the show, with Pablo.
Yeah.
Pablo and Lukasz in the core.py podcast. That they've, of course, asked core developers and I guess main developers of the REPL and some other things. On their podcast, they've talked in depth about these things, and they have much more knowledge about the details there than we do. And it's been really interesting to follow them as well. So that would be a great place to go if you really want to know more about the details of this.
Yeah, they've definitely been doing those deep dive series and definitely have the connections with the core developers. And sometimes it may shoot way over your head, but depending on what you're looking at getting into. But yeah, that's a good resource. Well, great. Well, Geir Arne and Christopher, thanks for coming on the show again.
Can I have next week off?
Yeah. I'm going to be in Hawaii. So
excellent.
All right. Talk to you both soon.
Bye.
Talk later. Bye.
And thank you to NVIDIA. NVIDIA is offering free, hands-on courses to help you accelerate your workflows and tackle challenges with AI. Ready to boost your skills? Enroll now at developer.nvidia.com/join. I want to thank Geir Arne, Hjelle, and Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.